Okay, so let's go back to the zoo with the gorillas and llamas. Remember these tables? In this one, we have animals' names, species, and birth dates. In this other one, we have species and the foods that they eat. Suppose that we wanted to find out how many individual animals eat fish. Well, that's a how many question, so we'd need a count aggregation. But what are we aggregating? The animals table doesn't talk about food, and the food table doesn't say how many of each species we have. But suppose that we could get a table that added the food column to the animals table. Then we would have something that we could count up. We saw earlier that we can derive a new result table from existing tables by doing a join between those tables. That'll give us something like this. Select animals.name, animals.species, diet.food, from animals join diet on animals.species equals diet.species. But we just want the animals that eat fish. We saw earlier that we can ask the database for just rows matching a particular criterion with a row restriction like this one. The same query, but now it ends with where food equals fish. So to answer the question, how many individual animals eat fish, our query will have to do three things. First, it will join animals with diet using species as the match. Then it will do a restriction, selecting only rows where food equals fish. And finally, it will do an aggregation to count the rows. Something to think about. How many rows will be in each of these tables? Just as the tables are related to each other, so too are the row counts. Let's imagine that we have 100 animals in the zoo, and that the final answer that we get from our query is that 20 of them eat fish. Remember that every result we get back from a database query is a table. That includes the result of this count aggregation. The count table has just one row and one column, and it contains the number 20. Well, that means that the result of filtering for food equals fish must have had 20 rows. Now, we don't actually know how many rows this join has, but it's got to be at least 100 rows, since each animal eats at least one kind of food, but some animals eat more than one, like bears, which eat fish and meat and fruit too. And we don't know how many rows the diet table has, but it'll be at least as many as the number of distinct species in the animals table. Again, that's because each species eats at least one kind of food.